All right. So how far did we get yesterday with you guys on the mini review? We're ready for number 3? All righty. Number 3. Oh, I think it might be what I'm erasing right now, actually. Number 3 says, find f of x minus 1. So what do? You can do this. Do not make this hard. It is easy. Well, how do we find f of x minus 1? Plug in x minus 1. And then we do the simplification. So every time I see an x, I'm putting in x minus 1. Every time I see an x, put in x minus 1. And then I recognize this is a square. So x squared minus 2x plus 1. I have to FOIL that. Please do not do whatever weird things you do. FOIL that. That's a FOIL. And then we'll distribute. And then we'll collect like terms. And we will get our final answer, which is 3x squared plus 3x minus 8. Is that right? Is that okay? All right, next, find the vertex. Now, the vertex, okay, this is a parabola, and you are most used to seeing a parabola written like this, but remember, p of x and y are the same thing. And your job is to find the vertex. What? 2s, exactly right. To get the x coordinate, we use negative b over 2a, which would be 6 over 6, 1. So for our vertex, the x coordinate is 1. Jack, these were given out a long, long time ago. Now, you're not done though. You want the whole vertex, so what do we need to do? Plug in 1. So when we plug in 1, we get 3 minus 6 plus 1, which is what? Negative 2, isn't it? So your vertex is at 1, negative 2? All right, number 5 says solve. Now, it doesn't tell me how to solve, it just says solve, so I get to do it however I want. What are some options I have when I look at a quadratic equation? This is a quadratic equation. What are some options I have? I could try to factor it. This one doesn't factor, but that's always an option, you know, consideration. Quadratic formula or complete the square. Now, this doesn't factor. If I were going to complete the square, I'd have to divide by 2, which means I'm going to have a bunch of fractions, so I'm going to use the quadratic formula, which I have memorized. You need to have memorized also. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Uh-oh, 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 I'm going to get a negative under there. So how do I handle that? My discriminant came out to be negative. So I pull out an I, and I'm done. Now, obviously, nothing cancels in this problem. If this had been a, let's say an 8, still nothing cancels in the problem. Remember, if you're going to cancel, what has to happen? It has to be all 4 places. So if we had a number out here, we could take a 2 out of everything then, right? But the way it was here, nothing would cancel. Even though you have 8 over 4, nothing cancels. All right, write as a single logarithm. All right, what's step 1? We're going to write as a single logarithm. Step 1.
Is that C?
goodness gracious.
Equal to 0.
No. Well, the first thing you have to take care of is this guy right here. He is messing everything up. Ultimately, we want to write this as one logarithm. Instead of having 3 separate logarithms, we want 1. But we can't start putting them together until we deal with this, and what happens to that? It becomes the exponent. So we have ln 7 plus ln q squared minus ln c. Now I've got to put together the 7, the q squared, and the c. So 7 and q squared are going to get multiplied and c is going to get divided. Why? Because addition of logarithms means multiplication of the numbers, and subtraction means division of the number. 7 is a logarithmic equation that needs solved. How do we solve that? It's real easy.
4 to the 2.
Yep, that's exactly right, Brenton. 4 to the 2nd equals x plus 5. One of my classes calls that loop-de-loo. I think there might be a teacher in Algebra 2 that calls it loop-de-loo. I'm not sure. But it's 4 to the 2nd equals x plus 5. So 16 equals x plus 5 and x equals 11. When you solve a logarithmic equation, you want to go back and make sure that whatever number you get, if you plug it in, it keeps this positive. This has to be positive. So obviously no problem with 11. But if this had been x minus 13, then 11 would not work. Do you see that?
So it would be undefined.
Be no answer. Right, that would be an extraneous root, so there would be no answer. Alright, number 8. Find the polynomial whose roots are 3 and 2i. Alright, now there are a couple of levels of this that you have to think about. So what's the first thing that pops into your head when I say a root is x equals 2i?
You have to have negative 2.
You have to have negative 2i also. Now nobody's telling you that. You're supposed to know that imaginary roots come with their conjugate every time. Now, how do you write the polynomial that has those as roots?
You multiply it out.
You multiply together the factors. So if you think about when you solve an equation, like a little bit ago you were talking about maybe factoring that one thing, when you get x equals negative 2 and x equals 1 as your answer, what was the step right before that? These are the factors. So now you have the answers. You must create the factors. That's what you multiply. You don't multiply 3, 2i, and negative 2i. That'll just give you a number. You need to multiply the factors. So this factor would be x minus 3, x minus 2i, x plus 2i. Those are your factors. That's what Dylan wants us to multiply together. So I always start with these because since they're conjugates, stuff will cancel out. So we get x squared plus 2ix minus 2ix minus 4i squared.
So it would be x plus 4.
X squared plus 4. Remember, I squared is negative 1. So every time you see an I squared, you have to think of it as negative 1. Who are we missing today? Anybody? Clark is missing. Oh wait, that's not today. All right, who else is missing besides Clark? Brooke. Oh yeah, she told me she was doing something today. Is that it? Everybody else over there? Everybody here? All right, so what did you get as an answer? You got to take that times x minus 3. So x cubed minus 3x squared plus 4x minus 12. There's your polynomial function. That's the polynomial that had the roots that you were given. This is supposed to be ringing some bells. Put little stars next to things you need to go back and review some more. Oh, this is new stuff. This should be fresh in your mind. Given that angle V is an acute angle, what does that mean? It's an acute angle. Less than 90, that means when I draw my butterfly bow tie, it will be in quadrant 1. So I have an angle in quadrant 1. And its tangent is 7/8. Opposite is 7, adjacent is 8. Tangent, 7/8. Pythagorean theorem would say that other side, if I added right, is a square root of 113. A squared plus b squared. And I want to know the sign. So 7 over root 113 or 7 root 113 over 113. Since I'm in quadrant 1, I do not need to worry about negative signs, right? Everything's positive. Okay, number 10 has a little star by it. That means calculator. We need a calculator to do this problem. How do we do this problem? We take the natural logarithm of both sides. And anytime you have an ln and an e back to back, they cancel. So 3x plus 4 equals ln 11.
Minus 4.
And 3x equals ln 11 minus 4. And then, yes, Brenton, we're going to divide by 3. So our answer would be ln 11 minus 4 divided by. Did you get negative 0.534? Is that okay with everybody? All right, next. List the possible rational roots. We call them PRRs. List the possible rational roots of this function. All right, so what would the possible rational roots be? Always plus or minus? Factors of 2 over factors of 3. So if we're listing those, it would be 2 and 1 for sure, but then what else? 2/3 and 1/3. There are the possible rational roots. All you had to do in this problem was list them. If you had to actually find the roots, those are the numbers you start with, right? And try to plug them in and get 0. All right, 12 is a calculator problem. How long will it take 123 bacteria to grow into 567 if the growth constant is 11.2% per day? This is a PERT. This is a PERT problem. So what goes where in this problem? What goes where in the PERT formula? 567 equals 123 e to the r is 0.112 t. Do I know t? That's how long. Okay. Oh my. Okay. What do I do? First I divide. Step 1, you have got to divide. Do not think about taking the logarithm until you've divided. Now we know we're going to need a logarithm because anytime the exponent, or anytime the variable is in the exponent, we know we're going to need to use logarithms to solve. But I can't do that until I get rid of that 123. So now that I've gotten rid of the 123, I can ln both sides. So ln this fraction equals 0.112t. So t is simply going to equal that fraction divided by 0.112. So ln I got about 13.64 days. Is that right?
Yeah.
All right, 13, consider the square root function. Oh, good grief. Oh, this is a blast from the past. The square root function. What's it look like? This is the square root function. Y equals root x. What's it look like? It's this one. That's exactly right. That is your square root function. If you can remember that picture, you can answer all of these questions. What's the domain? Is 0 to infinity, including 0. 0 is a closed-in dot there. 0 to infinity, that's your domain. What's your range? Same thing. Isn't the range the same thing? Zeros. It has 1 0, yeah. It has a 0 at 0 0. A 0 is another word for x-intercept, and don't we intersect the x-axis right there?
Yeah.
So that would be a 0. Intercepts. Now, zeros are x-intercepts, right? So that's the same thing. What's the y-intercept? 0 0. That point is not only the x-intercept, it is also the y-intercept. Would you say this is an increasing or decreasing function? Increasing on its entire domain. Does it have any asymptotes? Nope, no asymptotes. Bounded. Now remember, bounded means ceiling and floor, or ceiling or floor. So this is not a bounded function, but it is bounded below. It's bounded below at y equals 0. In other words, it has a floor. Does it have a ceiling? No. And if you're going to be bounded, you have to have both, a floor and a ceiling, like the sine curve. But this one you could say is bounded below. All right, I stuck a couple more in up there. 14. This is recent. Everybody gets this one right. Nobody misses this. The secant, or excuse me, the sine of 5 pi over 3. Sine of 5 pi over 3. Well, first of all, what's 5 pi over 3? 300. So we're going to find the sine of 300. This is 300, has a reference angle of 60. So the sides are root 3, 1, and 2. Anything negative, I'm not in quadrant 1, so something will be negative. The root 3 is negative. And I want the sign. All right, what's the sign? Negative root 3 over 2, opposite over hypotenuse, negative root 3 over 2. And 15, find the inverse. All right, how do we find an inverse? Does anybody remember the steps we go through to find an inverse?
The x and y.
All right, so the first thing I'll probably want to do is put a y into my problem. I don't even have a y in this problem, so I'll put one in. So y equals 2x minus 1 over 6. Now I'll switch them, so x equals 2y minus 1 over 6. Remember this? And then I will just get y by itself. So 6x equals 2y minus 1. 6x plus 1 equals 2y. And my inverse is 6x plus 1 over 2. Right? Okay. Now, quickly, I know we did the first two yesterday, but I don't think I videoed, so I want to make sure we at least talk about it again. How do we find the remainder? We have two ways. What are our two ways of finding the remainder? We either do the division, and that would be a negative 2 out here in the box, right? Or you just plug in -2. And whatever that equals is the remainder. And then for number 2, all 3 of those, it doesn't matter what the equation is. If you are finding a y-intercept, what do we do? Plug in 0 for x. That's it. You plug in 0 for x. That's how you find a y-intercept. Okay? All right, so we got that done. All right, so now I've got a few problems that I jotted down. I was waiting to give blood this morning. So let's get our calculators out, because I think these might all be calculator problems. Okay, so.
Are these just for the,
No, you don't have to. You're going to write them down though, because if I were writing an exam and I needed a section of free response questions, that is ones that aren't multiple choice. These are kind of some of the questions that I would focus on. And since I did write the exam, and there is a free response section, these are probably things you want to know. All right, so let's say if you sneeze once, you need 4 Kleenex. If you sneeze twice, you need 9 Kleenex. If you sneeze 3 times, you need 20 Kleenex. And if you sneeze 4 times, you need 37 Kleenex. The question is, what if you sneeze 10 times? How many Kleenex do you need if you sneeze 10 times? All right, how in the world are we going to approach this problem?
the stat plot?
Exactly. You've been given a set of ordered pairs. You've been given these groupings. Right? So we're going to go ahead and let our calculator graph those for us so that we know what kind of an equation this is. Right? Do these points lie in a straight line? Do these points lie in a parabola shape? Do these points lie in, I don't know, exponential shape? Let's just see how they lie. So what do? We go to stat, and we're going to edit. Now, if you already have numbers in there, you need to get rid of those. We don't want those numbers in there. This is going to be L1, and this is going to be L2, right? So let's get those in. If you've forgotten how to do that, lean over to your neighbor. Maybe your neighbor remembers. So we're going to get those in there. Now, you also, for this purpose, you need to go into stat plot and turn it on. Yeah, you need to have plot 1 turned on or it won't work. I mean, obviously you want it turned on. It's the very first button on the calculator, Michael. Okay, now also, I want you to look at your window because you're going to ask the calculator to graph these points, right? Look at the X's. So tell me about your X window. What do you need in terms of your X window? Maybe 0 to 5?
You want to find 10?
No, you're not going to get, 10's not going to plot. You don't have a Y coordinate. We're going to get to that in a minute. These are the only points we have.
So you just want to go for it.
So we got 0 to 5 maybe on our X's, and maybe 0 to 40 on our Y's. Now, if you have an equation in there, press Y equals, and if there's something in there, clear it out, because you don't want to see that. You just want to see your dots. So go ahead and press graph. What did you notice? What does it look like? Is it a straight line? Does it have a little bit of a curve to it? So somebody said maybe it's exponential. Somebody else might think that it looks like part of a parabola. I'm gonna go with the parabola thing, but it could be, you could write it as an exponential. You will have to make the decision unless the problem says write an exponential function for those points or write a quadratic function for those points. If the problem doesn't say, then you pick. Based on what you see, you pick. So I'm picking quadratic. Looks like the top half of, or the right side of the parabola to me. So I'm picking quadratic. So now what do? I go into stat again, but over to calc, and then down to whatever regression I'm picking quadratic. So I pick quadratic regression, and it should give me a value for A, B, and C. Did it? What does it say? Y equals? What's A? 3x squared. What's B? Minus 4x. What's C? Plus what? 5. So there is an equation that fits these data points. So now I am going to actually answer the question. I want to know how many Kleenex it takes if I sneeze 10 times. So all I have to do is plug in 10. Oh my, it's going to be a big number. So it takes 265 Kleenex if you sneeze 10 times. Now, if you're fuzzy on that, then you want to practice a couple of those and make sure that you're okay with that. Now, I also want to remind you that we turned on the stat plot to do the problem. We had to. But for some of you, depending on your particular calculator, it will not let you graph regular stuff if the plot's on. So turn it off, and then you won't have any trouble graphing your other things. All right, let's see what else I've got here. All right, so now I've got this problem.
Miss Flores?
Yep.
You want your calculator to decrease your radius?
Makes absolutely no difference. Unless you are talking about angles, it makes no difference. This problem has nothing to do with angles, so it doesn't matter. You only care about degrees and radians if you are inputting an angle or outputting an angle. If you want to know what an angle is, or if you want to put in an angle, then it matters. But otherwise, it never has anything to do with it. All right, now you'll recognize this one. I have a piece of paper that's 12 by 30. Infamous box problem. We're going to make a box the way we always make a box. I'm not going to write down all the instructions. You've done this 100 times. You're going to cut out the corners. They're square corners. And ultimately, we want to find the maximum volume. That's our ultimate job. Now, I'm going to ask you several other questions. So we'll work through that. But everybody remembers what we're doing here, right? Folding up the flaps, making the box. Okay. So the first question is, write the equation for the volume. Write the equation that represents the volume of the box. So what would that volume be? And if you say length times width times height, you're in the right direction, but that's not what I mean. What is the volume for this specific box? 30 minus 2x. That's this dimension right here. 30 minus 2x. 12 minus 2x. That's this dimension right here. Times x. Because that's the height when you fold up the flaps. So that's the equation of the volume. Okay? And you don't multiply it out. Now, what's the domain?
So it's going to be like 12 minus 2x.
No. What are, well, maybe I shouldn't have spoken yet. Finish your thought.
So I said it. 12 minus 2x is greater than
Okay, so actually less than or equal to 0. Less than, actually just less than. We know that whatever x is, it can't be more than what? 6. It can't be more than half the smallest dimension. So your domain is all of the x's between 0 and 6. Clearly, x has to be bigger than 0. You can't have a negative x, right? But if x is bigger than 6, this isn't possible. Do you see that? So your domain is everything from 0 to 6. Then I might ask you for the dimensions of the window that you're going to use when you graph this. Half of that's already answered. What's x min? Yeah, x min and x max are 0 and 6. Y min is also 0. What's y max? No idea, right? No idea. So I'm going to pick a number. I don't know, 300. And I'm going to see what happens. What do I need to have happen? If 300 is okay, and it's a random guess, I have no idea. If 300 is okay, what will I see on my screen here? I'll see a hill. Right, I got to see something that looks like that. It won't be a perfect parabola. It doesn't matter. I just need to see a hill. Remember, if you have issues, it might be because your plot is still on. It might be because you didn't change your window. Might be because you typed in the wrong equation. I don't know. Oh, 300's not big enough, is it? So I need to make that a little bit bigger, maybe 500. Okay, so 500 worked. So the dimensions, my x min and max, that's my domain, 0 to 6. But my y min and max, my range, I've got 0 to 500. That works. Could you use 0 to 600? Yeah. As long as you see the hill, it's fine. All right, then you remember how to find your maximum? Haven't done that in a while. We did it a bunch back when we did it, but how do we find the maximum? Second calc, and then set left bound and right bound, right? And then take a guess, and my maximum is 2.64, 438.56. Now 55. So the ultimate question was, what's the maximum volume I can create from this piece of paper? And the answer would be 438.55. If these were inches, it would be square inches, square feet, whatever. Oh, volume, thank you. Yes. Yes, indeed it would be. Volume. Cubic, thank you. All right. All right, so somebody throws a ball off the roof. And the height of the ball after t seconds is given by this equation. All right? So somebody throws a ball up off the roof, and the height of the ball at t seconds is given by this equation. So here are the questions. There are 3 of them. What's the height after 2 seconds? What am I going to do to find the height of the ball after 2 seconds? Just plug in 2. That's a no-brainer. We can't be missing that. Here we go. There's 16. I got 150 feet. Do they match that? second question. What is the maximum height? Now, there are a couple of ways you can do this. If you have a calculator for this problem, and you wouldn't necessarily have to have one, but if you had one, could we just graph that and do what we did over here? Yep. What if we don't happen to have a calculator and we want the maximum of this equation? What is this equation? It's a parabola opening down. So the maximum is just another way of saying vertex, right? Which would be negative b over 2a. So you need to be prepared. You don't know whether this is, you're going to have a calculator to do this or not. This one you absolutely will, because we don't know how to find the maximum of the cube. So this one we will have a calculator. This one you may or may not. So if you have one, you can do exactly what you did here. If you don't have one, then you're going to do negative b over 2a. So it looks like the time it reaches its maximum height is 132s, which is 25/8. Right?
I put it in decimal form.
You can put it in decimal, it doesn't matter. Now remember, if you don't have a calculator,
Yeah.
but yes, it doesn't matter to have it as a decimal. Okay, now that's when it reaches the maximum height. So if the question was, when does it reach its maximum height? After 25/8 seconds. But what is the maximum height? What will I need to do? I'll have to plug that in. Well, I'm going to use my calculator to plug that in. Because I'm just not up to. I could do it by hand if I had to. Hopefully, if Mrs. Ford, when she does by hand, she'll use nicer numbers than this. But I got the maximum height is 320.25 feet. Did I do that right? Anybody else get that? Uh-oh. Oh, yeah, I see my mistake. I see it. Good grief, I got 2 mistakes on this video. This is embarrassing. Yeah. Well, I don't know what it is, but it's not what I wrote down. Yeah, it's 170.25. A little bit of a difference there.
Just a tad.
It's just a tad. Okay, so if the question was, when do we reach the maximum height? Then it's the 25/8. It's the x coordinate of the vertex. That's the time. If it is, what is the maximum height? Then I plug that in and get 170. And then the third question is, when does it hit the ground? When does it hit the ground? So what do I do here? Put 0. So I set this equation equal to 0. Because if it's on the ground, h is, the height is 0. Now, again, if you have a calculator, you can use the calculator to find when it hits the ground, can't you? That would be instead of going to second calc max, you go to second calc 0, and you can find that point. If you don't have a calculator, you need to solve that equation. Well, what kind of an equation is that? Well, yeah, it's quadratic. And if I want to solve a quadratic equation, we've already talked about this.
Oh yeah, you can do square.
I can either complete the square, quadratic formula, or probably not factor that. Right? Factoring is an option, but probably not.
Quadratic formula.
So when I do, let's say I do my quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. When I do this, I'm going to get two answers. And those numbers are hideous, so of course we're going to type those into our calculator. But when we do that, we're going to get two answers. Be careful. Probably one of them is going to be negative. Yeah, I don't think they're going to be 0, but one of them is going to be negative, which we don't want that one, right? So when is the ball on the ground? Whatever the positive answer it comes out of that is, that's the answer. So like 15 seconds or something. Okay? Alright, I got one more, but I'm going to have to save it for tomorrow. And tomorrow also would be the time, if there is something, if you kind of want to take a glance through the review sheet, if there's something on the review sheet that you think, oh my, I don't remember that, tomorrow would be the time to ask, since it's your last chance. Okie dokie, Smokies.
Are you gonna have class Monday?
We do.